Dear students, in this lecture, we will be discussing how to represent a point in three-dimensional space, either in a Cartesian system or cylindrical system or a spherical system. Now let us take here some examples. Okay, so in Cartesian system, any point is represented as x, y, z. And here, as an example, I have taken 5, 4, 3, which is equal to x, y, z. Similarly, in a cylindrical coordinate system, so any point is represented as r, theta, z. So where here I have taken an example of 5, 5 by 2, 5, which is equivalent to r, theta, and z. Similarly, for spherical coordinate system, we have the coordinate axis as rho, theta, and phi. And here, as an example, I have considered 6, 5 by 2, and 5 by 4. And you can also notice here, while plotting, actually, the system will take only the numbers. Okay, it will not take the special characters like pi. So that is the reason we have converted this pi by 2 as 1.57 here. Similarly, the pi by 2 is 1.57 and pi by 4 as 0.79, where value of pi we have considered for converting is 3.1415. Okay, so now let us try to plot these points on the Cartesian system, cylindrical system, and spherical systems respectively. So first let us talk about the Cartesian or rectangular coordinate system. So here the point taken for plotting is 5, 4, 3. So let us enter that value. The x value is 5, y value is 4, and z value is 3. Then how exactly it is going to plot? So it will move along the x-axis the 5 units like this, and from here it will move along y-axis the 4 units like this, and then from here it will move in the z-axis 3 units. So this is a final point, so which is equal to 5, 4, 3. So this is a point on the Cartesian or rectangular coordinate system. The value is 5, 4, 3. Now let us move on to the second coordinate system and its representation. Okay, so cylindrical coordinate system. Here in this we have taken an example of 5, 5 by 2, 5. Okay, so equivalent numbers are 5, 1.57 and 5. So I have entered here r value as 5, theta value as 1.57, and z value as 5. That is equivalent to 5, 5 by 2, 5. Now let us see how this is going to be constructed. So first let us draw along the x-axis the 5 units, that is the radius. We are plotting here 5 units along x-axis, and this location is theta is equal to 0 degrees. Now from here, as x as a reference, you will measure an angle of 5 by 2. That is 5 by 2 we are measuring. So if I want to measure 5 by 2, that is the angle between x and y, because they are orthogonal to each other. And the angle between these two things is going to be 90 degrees. Also along y-axis, the theta value is going to be 90 degrees, or it is 5 by 2. Now from here, we have to move z-axis. Okay, along z-axis 5 units we have to move. So like this we will move, and this is a point which is equal to 5, 5 by 2, 5. Okay, so this is a point 5, 5 by 2, 5. Now let us move on to the third coordinate system and representation of a point. So when we look into the third coordinate system, a spherical coordinate system. In the spherical coordinate system, we have taken an example of 6, 5 by 2, 5 by 4. And it is rho, theta, phi. So now here, this is a theta axis. You can observe here, this is a theta and this is a phi axis. Okay, this is phi and this is theta, rotations. Okay, so now when I have taken here 6 as a radius, so rho is equal to 6. I'll be moving here with rho is equal to 6. Once I move here with rho is equal to 6 units. Okay, then what I do, I'll move along the theta. So theta I have to make here 5 by 2. That means I'll be moving from here to here up to here like this. Okay, so then what I do here, so once I do this, from this point we have to draw an arc which is crossing through this point. Keeping this as a radius, we have to draw an arc, okay, between this point and this point, which is intersecting the z-axis here. Okay, so now this thing we are going to draw here. And now, so in order to mark this phi, what we are doing, so phi is a 5 by 4, so we are marking here 5 by 4 from here to here. So this is the value, and this is the point. So this is the point 6 comma 5 by 2 comma 5 by 4. So this is a point which is 6 comma 5 by 2 comma 5 by 4. Okay, so this is how we are representing the points in 3 different coordinate systems, and the references that I have taken for these things is the 3 website links that I have given here. You can refer to this, and the same demonstrations I'm going to show you here. Say, let us go to that websites. So first is, I'll go to the Cartesian system. So when you look into the Cartesian system, when I have entered here, say, let us see, we can animate this and we will check into it. Okay, so here I have taken x is equal to 5, y is equal to 4, and z is equal to 3. So now when I move the slider, so what will happen? So first it will plot the x-axis 5 units, yes, and then after reaching 5 units it will go to y-axis 4 units. Once it reaches that, it will start with the z-axis 3 units. So this is the point. This is a point that what we got as a final point 5 comma 4 comma 3. Okay, so this is the likewise you can represent any point here. You can enter any point and you can work out with this. Okay, so that is possible. Let us take an example, okay, of another point, how we can plot it. Okay, I will show you plotting another point on the coordinate system. Say I want to plot here 2.5, and then here I can plot say a 3, and here I can put somewhere around so 2, or let it be minus 2. Okay, so now let us see now how it is going to be. X-axis it is going to be 2.5. See, it's going 2.5, then it is going y 3 units. Afterwards it is going to minus 2 to the bottom. So now the point here is this point. So this point is equal to 2.5 comma 3 comma minus 2. So this is the point 2.5, 3 and minus 2 is this point. This is about plotting a point in the Cartesian coordinate system. Now let us move on to the cylindrical system. In cylindrical system, erase this first. In cylindrical system, here I have taken 5, 1.5 and 5. So this 1.5 corresponds to 5 by 2. Okay, so if I get 0.75 is right. So let me just check that. So if I put 0.79 here instead of this, so now what it will happen, 0.79 if I'm putting. So observe now, this is going to be like this. Let me just plot it. That is equivalent to 5 by 4. This is 5 by 4 now, right? 0.79 is 5 by 4. Now when I do that, when I plot it, actually what it will do, it will first plot along the x-axis, because this is a theta is equal to 0 reference line. Along this, first the radius will be plotted. It will be like this. Okay, now let us say I'll just keep moving this one and I'll show you the same thing. So now the radius 5 units it has moved, and afterwards it is making a theta angle. See, it is making a theta angle. How much it is? 45 degrees. That means a line between x and y axis, that is a 45 degrees. Okay, so once it reaches 45 degrees, it will go to vertically 5 units. So that is this one. If you observe now, sorry, yeah, so 5 units it is moving. So this point is corresponds to 5 comma 5 by 4 comma 5. So likewise you can plot any point on this cylindrical coordinate system. Let's move on to the third coordinate system, which is a spherical coordinate system. So let us move to the third coordinate system, which is a spherical coordinate system. So here, let me just put it initially. I'll just put it as a full screen mode. Yeah. So here, the point what I have represented is 6 comma 5 by 2 comma 5 by 4. This is the point that we have plotted, right? So 6, this is equal to 5 by 2, and this is equal to 5 by 4. Okay, so now when I do this, so what is going to happen? Let us see here the animation. So first it will plot radius along x-axis, say 6 units it has plotted. Then it is going to plot the theta. So now it is going to plot the theta. Okay, so it is just taking the radius along x-axis and z-axis as a reference, and then it is plotting the theta. So once it plots the theta, so then it is going to plot the 5 by 4 along phi axis. You observe now. So this is the point. So this is the point. Say it is going to be 6 comma 5 by 2 comma 5 by 4. Okay, so I hope you understood this plotting of points on coordinate systems. Okay, if you have any questions, you can comment on the video. Okay, so thanks for watching, and for more videos you can subscribe to my channel. I'll be putting more and more videos on the vector analysis and the electromagnetic field theory. Thank you.